Good afternoon, everyone. I'm Himanshu. I am a CS grad student at the University of California, Irvine, and this is my first time using and working with LLVM. So today, my teammate Nikhil and I will be talking about a proposal for the TableGen formatter. So let me start by giving you an idea of the extent of use of TableGen. So these graphs here show the number of lines of TableGen code over the years in LLVM and MLIR respectively. And if you focus on the increase in the number of lines of code, especially in the second graph, you can see that it has been over threefolds in the past 3 to 4 years. Now, despite this extent of use of TableGen, there is not really any code formatter for it. And that leads to inconsistencies in code such as this, where you can see there's a difference in the indentation. Or this, where depending on the coding style, there may or may not be braces, and many others. And it is these inconsistencies that call for the need for a TableGen formatter. So the first approach that we thought of was pulling out relevant files from Clang-Format and reusing them as shared libraries. Now, the advantage here is that the TableGen formatter would be a completely independent tool. But it turns out it's quite difficult to do that. The second approach we thought of was a slightly radical approach, which was building everything from scratch. Once again, the advantage here is the same, but the disadvantage is that this would introduce a lot of code duplication. The third approach we thought of was adding TableGen support within Clang-Format. Now, the disadvantage here is that TableGen would then be a part of Clang-Format and therefore would be completely dependent on it. But a major advantage here is that we can reuse the existing infrastructure. And as you might have guessed from the title of the presentation, we went ahead with the third approach. Now, let me give you a brief overview of our implementation. So these blocks here are some of the major components of Clang-Format. And while I won't be going over the details of these components, I'll talk about how we've modified them to accommodate TableGen. So first off, we added support for TableGen keywords like def, then, multiclass in the format tokens. Next up, we modified format token lexer to merge tokens such as the bang operators to be treated as single tokens. Some of the major changes were in the unwrap line parser, where we added support for parsing def records, if-then conditionals, for-each loops, and other TableGen constructs. In the token annotator, we determined some formatting rules based on token semantics. For instance, when you're using hashtag as a concatenation operator in TableGen. In the token analyzer, we reused existing Clang-Format style options such as insert braces and remove braces LLVM to be applied to TableGen as well. And finally, we ensured that the spacing manager files indented the TableGen code properly. Now I'll hand it over to my teammate Nikhil to continue the presentation. Thank you.
Good afternoon. So I'll continue with the testing of the formatter. So first we ran all the TableGen files under the LLVM project through the formatter, on which after the formatting process, we ran all the regression tests in the LLVM project using the check LLVM target. So overall, we have successfully formatted all the 802 files in the LLVM project without any build issues. So here are some examples of the TableGen formatter. So the first step in the formatter is to recognize the TableGen keywords, which are def and multiclass. So on the right, you can see that a new line was added here, as the formatter recognized the def and multiclass as two separate definition blocks. And similarly, the insert braces, where the optional braces were added only after recognizing the in keyword. Similarly, we also passed unrecognized loops and conditionals, where only after the in and then keywords there were the optional braces that could be removed or added. Like as you have seen in the previous examples, we have also added support for a few of the existing Clang-Format options. One another such example is the align consecutive assignments. As you can see on the top, the assignments have been uniformly formatted. Okay, but if you see at the bottom, the assignments inside the multi-line code block, which have not been formatted. So which brings me to the future works. So one of the first action items is to format the multi-line string literals seen in the previous example. And then we'll continue adding support for the other TableGen keywords and constructs. And finally, we'll add support for the remaining Clang-Format style options, which are relevant to TableGen. So we would like to especially thank Min for providing his guidance and support throughout the course of the project. Thank you.